Problem 4 of the mock exam. Consider the curve y equals natural log of 3x minus 1. Let P be the point on the curve where x equals 2. Okay. Write down the gradient of the curve at P. Well, how do we find the gradient of the curve? That's just another way of saying find the derivative. So, we're going to find the derivative of this function, natural log of 3x minus 1. That's not a hard derivative. It's basically 1 over the inside of this, and then the chain rule, which is multiplied by times the derivative of this, which is 3. So basically that's 3 over 3x minus 1. Then we're going to find the value of the gradient at x equals 2. That just means that we're going to substitute the value of 2 in for x. So we're going to get 3 times 2 in the bottom minus 1, which is 5. So the answer for the gradient of the curve at P is 3/5. Okay. Basically, if you're going to imagine what this looks like. There is a log curve, which looks kind of like that. X equals 2, or the point P is a point right here. And then the tangent to the curve, or the slope of the tangent to the curve, is right there, right? And so the slope is about 3/5, it says. 3/5. Kind of looks like that, okay? Just for you to envision it in your mind. Last part. The normal to the curve at P cuts the x-axis at R. Find the coordinates of R. Okay. The normal to the curve is a perpendicular line relative to the tangent line. So the tangent line kind of follows the curve. The normal line is perpendicular to the curve, kind of like that. So they're saying, where does this normal line cross the axis, or across the x-axis, right? So they're saying that this is point R, and they want us to find point R. Well, the first step to finding where the normal line crosses the x-axis is to find the equation of the normal line. And if you remember from your problem sets, in order to find tangent lines and normal lines, it is very handy to use this equation, which is not in your formula booklet. You need to memorize it. It's called point-slope form. With this form, if you know two things, if you know the slope of the line, and you know one of the points on the line, which is not an x-intercept or y-intercept, it is any point on the line. If you put those three numbers into the equation, you then have immediately the equation of a line. So, first of all, the slope of the normal is perpendicular to the slope of the tangent. We already found the slope of the tangent. It's right here. The slope of the normal is, basically what you do is you invert it, and you put a negative on it. So negative 5/3, which is rise of -5, run of 3, is the perpendicular line to this line here. So this pink line is, the slope is -5/3. Okay? So the slope is -5/3. We're going to put that in there. And then we want to know the coordinates of this point, P. Well, it turns out that the point P has an x-coordinate of 2. They already told us that, right? Do we know anything else? Do we know the y-coordinate of P? Well, we can figure it out because we have a function which defines a y value for every x value. So, y equals natural log of 3 times 2 minus 1, natural log of 6 minus 1, natural log of 5. Okay, so the y value that corresponds to an x value of 2 turns out to be natural log of 5. And if you want to, you can put that in your calculator, but on this mock exam, we don't have access to the calculator, so we just leave it in that form, natural log of 5. It's just a number. It's probably about, I don't know, a little bit less than 2, I'm not sure. I'm just going to write it here. M is -5/3. and the x1 value is 2. I do not put anything into x and y right now because I want it to be the equation of a line. This is the equation of the normal line. Okay? Then finally it says, find the coordinates of r, which happens to be the x-intercept. The x-intercept, what's so special about the x-intercept is that the y-coordinate is 0. So now we can just put 0 in for y, and then we can find the x-intercept, right? So if we put 0 in for y, basically we have natural log of 5 equals negative 5/3 x minus 2. Multiply both sides by negative 1, we get natural log of 5 equals 5/3 x minus 2. And then multiply both sides by 3/5, we get 3/5 natural log of 5 equals x minus 2, sorry. Add 2 to both sides, we get x equals 3/5 natural log of 5 plus 2. And so they wanted the coordinates of r. So r is this point here. We just found out that it is 3/5 natural log of 5 plus 2, comma, 0, right? Since it's the x-intercept, the y-coordinate is 0. From the very beginning, we knew that. Okay? So we're going to write the coordinates here. We're going to put 3/5 natural log of 5 plus 2, comma, 0. That is the coordinates for r.